All right, mathematicians, let's get started with the algebraic reasoning, our intro to proofs, section 2.4. Our essential question, how can algebraic properties help you to solve an equation? So our objectives, mathematicians will be able to use algebraic properties of equality to justify the steps in solving an equation, also use the distributive property to justify the steps in solving an equation, and use properties of equality involving segment lengths and angle measures. All right, our first key point, using algebraic properties of equality. We're going to let A, B, and C be real numbers. First, we have our addition property. And our addition property states that if A equals B, then A plus C equals B plus C. So in other words, if I have the same value added to both sides, I still have equality. Next, I have the subtraction property, and it's similar to the addition property in that it states if A equals B, then A minus C equals B minus C. Again, same value, subtracted on both sides, keeps it equal and balanced. Next, we have our multiplication property, and it states that if A equals B, then A times C equals B times C. So we have scaled by the same factor on both sides. In other words, I've multiplied by C, or some value C, on both sides. Next, I have the distributive property. If A equals B and C does not equal 0, then A divided by C equals B divided by C. So I'm dividing the same value on both sides as long as it is not 0. And that's because you can never divide by the value 0. In fact, if you type it in your calculator, you'll get an error message. Then our substitution property, if A equals B, then A can be substituted for B in any equation or expression. And finally, we have our distributive property. If A times B plus C equals AB plus AC, where A, B, and C are real numbers. These are the properties that we'll be using in our algebraic proofs. All right, let's just start by justifying our steps, solving this equation, 3x plus 2 equals 23 minus 4x. And when I say justify each step, we're going to use those properties we just talked about. Well, first, let's just take a look at how would we solve this equation. Well, as you came into geometry, you've always solved equations by inverse operations. So the first step would be add to 4x on both sides, combine like terms, resulting in 7x plus 2 equals 23. Subtract 2 on both sides, resulting in 7x equals 21. Then divide both sides by 7, resulting in x equals 3. Well, you're going to do all of that, but this time you're going to show each step with a justification. So I've highlighted the main steps in green, and all of the black is the steps that we took to undo operations. In other words, do our inverse operations. Well, now with proofs, you're going to kind of put it formally. Equations or statements on the left side and your reasons on the right side. So let's fill in our table here. Our first step is to start with the given equation, and our reason is given. Our second step was that we added 4x on both sides. So notice we added the same thing on both sides, which means we're using the addition property of equality. Our third step is to combine like terms, in other words, simplify. And then our fourth step was that we subtracted 2 on both sides, and we subtracted the same value on both sides, so that means we're using the subtraction property of equality. Then we simplified, in other words, combine like terms, to get 7x equals 21. Our next step is that we divided 7 on both sides. So when you divide the same value on both sides, that's the division property of equality, resulting in x equals 3. Our final conclusion is that x equals 3, and our reason is that we simplified. So this is our introduction to proofs. We're going to start with what we already know from prior courses, and that's solving algebraic equations. Except now you're having to justify every step with these properties. All right, let's take a look at this next example. We're going to use the distributive property this time. So let's solve negative 5 times 7w plus 8 equals 30. So our first step is to distribute that negative 5 resulting in negative 35w minus 40 equals 30. Now we're ready to add 40 to both sides, resulting in negative 35w equals 70. We're going to divide both sides by negative 35, resulting in w equals negative 2. So again, just like you've always done with solving equations, except now you're going to justify in a 2-column format. So the left side of the column is equations, or in other words, your statements, and the right side is your reasons. We always start with the givens, so the first step will always be your given statement or equation. So in this case, negative 5 times 7w plus 8 equals 30. And the reason is given. Second, we distributed that negative 5, resulting in negative 35w minus 40 equals 30. So you've got your distributive property of equality as our reason. Next, you have negative 35w equals 30. How do we get that? By adding 40 on both sides, so we used our addition property of equality. And then finally, we get our final conclusion is x equals negative 2 because we divided negative 35 on both sides. Therefore, we used the division property of equality. So that's our 2-column proofs. Get ready to practice some more, even if you haven't gotten the hang of it so far with these first 2 examples. Bring clarifying questions and be ready to practice. All right, moving on to other properties of equality that we will use. So true for real numbers, segment lengths, and angle measures. We've got our reflexive property of equality, or POE, our symmetric property of equality, and our transitive property of equality. We can use it for real numbers, segment lengths, and angle measures. So let's take a look at each one of these. For the reflexive property of equality, with real numbers, any value equal to itself. So if I said 2 equals 2, or 3 equals 3, this is known as the reflexive property. In other words, it's like looking at yourself in a mirror. You see yourself in the mirror, so think of that as a reflection or reflexive property. So whatever you see on one side, it's equal to itself on the other side. So that's true in geometry. So the length AB is equal to length AB. And it's true for angle measures. So the measure of angle A equals the measure of angle A. This is known as the reflexive property. The same thing on both sides of the equal sign. All right, let's take a look at the symmetric property. Symmetric property says if A equals B, then B equals A. So it's like they switch sides. So that's going to be true for segment lengths. So if AB equals CD, then CD equals AB. And true for angle measures. So if measure of angle A equals measure of angle B, then measure of angle B equals measure of angle A. This is simply the symmetric property of equality in action, whether it's real numbers, segment length, or angle measures. All right, so let's look at the transitive property. Transitive property for real numbers states that if A equals B and B equals C, then A equals C. Notice that if A equals B is the first statement, and then B equals C, then see how A and C are equal to the same value? So that means A can be equal to C. And that can still be true also in segment length. So if AB equals CD and CD equals EF, then AB equals EF. Because AB and EF are both equal to the same length CD. So therefore they must be equal to each other. And then we have our angles. So we can also use transitive property of equality with angle measures. So if measure of angle A equals measure of angle B, and measure of angle B equals measure of angle C, then measure of angle A equals measure of angle C. So measure of angle A and angle C are both equal to the same measure B, therefore they must be equal to each other. All right, so let's just practice naming the property of equality for the statements illustrated below. So if measure of angle 6 equals measure of angle 7, then measure of angle 7 equals measure of angle 6. So notice all that changed was they just switched sides. Well, that is the symmetric property of equality in action. So that would be our reason for the statement, if measure of angle 6 equals measure of angle 7, then measure of angle 7 equals measure of angle 6. Take a look at this next one. If JK equals KL and KL equals 12, then KL equals 12. Sorry, JK equals 12. So this is the transitive property of equality in action. Notice that KL is both equal to JK and 12, so JK must be equal to 12. And then our last one is measure angle W equals measure angle W. Well, that's going to be this reflexive property. Think of it like a mirror, reflexive property of equality. All right, let's take a look at this example where we will practice using properties of equality with angle measures. All right, we've got this image. You reflect the beam of a spotlight off a mirror lying flat on a stage as shown. Determine whether a measure of angle DBA, so that's 2 and 3 added together, equals measure of angle EBC, which is angle 1 and angle 2 added together. So we'll start by setting up our 2-column proof, equations on the left side, reasons on the right side, and we always start with the given. We're given that measure of angle 1 equals measure of angle 3. How are we given this? Because I don't see it anywhere in this paragraph. Well, it's given by the arc marks in the picture. So these are things that you can conclude from a picture, therefore they are given. So I can state the measure angle 1 equals measure angle 3 because I'm given these marks. So my reason, given. And then from that we can conclude that the measure of angle DBA, so DBA, is equal to the measure of angle 3 plus the measure of angle 2. And that's by using the angle addition postulate. Remember, it's adjacent angles implies angle addition postulate. So this is where we will be using our implied statements in our proofs. So because 2 and 3 are adjacent, that immediately implies that we can add these two angles together. So that's exactly what we put in our proof. So here we can use the substitution property of equality because earlier in the proof we said that measure of angle 1 equals the measure of angle 3. Well, in our second statement, we put measure of angle 3 plus measure of angle 2. So that means if measure of angle 3 equals measure of angle 1, then I can substitute measure of angle 1 for measure of angle 3 in my next statement. And now I have measure of angle 1 plus measure of angle 2 equals that same angle, measure of angle DBA. And I use the substitution property of equality. Next, I can say measure of angle 1 plus measure of angle 2 equals measure angle EBC. So this time I'm saying 1 plus 2 equals EBC, and that's because of the angle addition postulate. So adjacent angles implies angle addition postulate. And now I'm able to have a final conclusion that measure angle DBA equals measure angle EBC, and that's by using the transitive property of equality. We had measure angle DBA equal to two different pairs of angles. So because of that, we can then conclude that measure angle DBA is equal to EBC. DBA is equal to two different pairs by the transitive property of equality. And that's it. That's our introduction to proofs. We will practice lots and lots of proofs, so if you didn't get the hang of it just by watching the video, no worries. We will continue to work through and clarify any questions that you might have. Just get ready to come in with those questions and get ready to practice. See you in class.